The last time we designed a sample of gear, and today we are going to make a proper approximate design of a gear tooth profile. Okay, so here is a question we're going to use. Let's look at this. Here is a question. It states, draw an involute SPUR gear profile showing all teeth with the given parameters below. We have the module 5 millimeters. This particular module, the module size gives the size of the tooth. The lower the module, the lower or the smaller the teeth, and the higher the module, the larger the teeth size. What am I saying? In essence, we can have a module as low as 432 millimeters, even less than that, and we can have as high as 20, 25, maybe 30, and maybe a little way above that, depending on the design. So the higher the module, the bigger the teeth. The lower the module, the lower or the smaller the teeth. So we have a pressure angle of 20 degrees. You know, the British standard they use 20 degrees, you know, most of the time as the standard. We can have 14.5 degrees as well. So we have number of teeth as 12. This is what is given. This is enough to plot a tooth profile. And I want you to know that we are not going to be able to plot the correct tooth profile. It's going to be an approximate method. Okay, so it takes a lot of calculation to, you know, plot a correct tooth profile. Especially the involute will cause a lot of issues. So we're going to use the approximate method. Let's go. Start drawing. First and foremost, we need to know 4 basic parameters of a gear. So I'm going to show us what I've plotted earlier. If you can see this, we have, I want you to see this first. This circle you are seeing here is called the dedendum circle diameter, and the top circle you are seeing here, this is a circle, this face is called the addendum circle diameter. And along this place, you see this place where these arcs were made, so along it, you know, from this point to this point to this point is called the pitch circle diameter. So, and there will be a circle below it called the base circle used to cut those arcs. Okay, so let's start right away. Since you know the basics now, we're going to first and foremost determine the pitch circle diameter, which is the most important of it all. So if you have the pitch circle, you can determine the addendum, the dedendum, then the addendum circle diameter and the dedendum circle diameter, and then we'll find the base circle. So we're going to use this. So this is the basic calculation we need to make. Pitch circle diameter, PCD, is module times number of teeth, which is 12 times 5, 60 millimeters. So we're going to go to home, draw center diameter 60 mm. Now, okay, we have this. Now we are going to the second one there. We have pitch circle diameter. We're done with that. The addendum is equal to the module, because the module gives the addendum. If the module is 5, addendum is 5 millimeter. If the module is 6, addendum is 6 millimeter. What does it mean? It means it's 6 millimeters away from the pitch circle, meaning there will be an addition of 2 times 5 to 60. What am I saying? Addendum circle diameter ACD equal to PCD, which is pitch circle diameter 60 plus 2 times the addendum. Okay, so let's go. Now we have 70 millimeters as the addendum circle diameter. That is it. Now let's find the dedendum circle diameter. You can see that for you to have the dedendum circle diameter, we are going to find the clearance first. I will explain this as when I'm done. So clearance is equal to 0.25 times module, okay, or 0.25 divided by the diametric pitch. Okay, so the diametric pitch is actually the number of teeth per unit length on the pitch circle. That is number of teeth, which is 12. Where is it? Number of teeth is 12 divided by 60, right? So that will be your diametric pitch, although we do not use that here. There are two methods to find your clearance. So that is the first one. The second one is what? 0.25 multiplied by module, which is 0.25 times 5, 1.25 millimeters. This will be added to your addendum. So 1.25 plus 5, which is 6.25, gives the dedendum. The dedendum is basically the distance or the radial distance from the pitch circle to the dedendum circle diameter. So that is the dedendum. Okay, while the addendum is basically the radial distance from the pitch circle diameter to the addendum circle diameter. Okay, all right. Now our dedendum circle diameter is pitch circle diameter minus 2 times the dedendum to have 47.5 millimeters. So the diameter is 47.5. Now we're done. We have pitch circle diameter, addendum circle diameter, and dedendum circle diameter, right? So we're going to draw construction lines, horizontal and vertical. Horizontal and vertical. So from here now, we are going to look at the number of teeth again. They said the number of teeth is 12, right? What does that mean? Meaning the diametral, this circular pitch CP is given by pi multiplied by module. This is the radial distance between one side of a tooth to the corresponding side on another tooth. Do you understand? So that gives 15.71. But instead of using your compass to be cutting an arc of 15.71, which could lead to serious mistakes, we are going to just simply divide our circle into 12 equal parts. One part for one teeth. So now we will divide the circle into 12 equal parts. Although we don't have to divide everything, we just need to draw one teeth and then make a polar arrangement. We don't have to design 12 teeth. This is not a paper drawing, it's AutoCAD drawing. So we're going to take a line to make some angles. I'm going to draw one teeth around this place. Now we know that from here to this place is 0, right? Like 0 degrees. You can see it there on the angle. So to this place is 90. I want to make it 30 degrees here. Okay, because if you look at the whole circle is 360 degrees, and we have how many teeth? 12. So if you say 360 divided by 12, you will be having 30 degrees, meaning 30 degrees per teeth. So we are going to make 30 degrees. If here is 90 plus 30 will be 120. So we're going to say, let's say 40 units. Hold shift on your keyboard if you want to input the angle, and press less than, then 120 degrees. So one teeth will be here, one tooth other will be between this place and this place. But remember, a tooth always have a spacing for meshing of another gear, like maybe a pinion or a bigger gear. So for them to mesh, there must be a spacing. So meaning this place, the teeth we are going to draw here will take only half of this space. For example, what I'm saying in essence is, look at this. There will be something like this. So meaning from this place to this place, from one side of a teeth to the corresponding side of or another teeth is called circular pitch. And this circular pitch from this place to this place is 30 degrees. I think you get that now. So we will just divide this and draw teeth on one of the sides. So we are going to draw another line to divide this angle. How? We know that this place is 90, right? 90 degrees, and this from this place to this place is 30 degrees. Half of it will be 15, since we are going to draw teeth on half of it. So 15 plus 90 will be 105. Therefore we can say 40 units as the line, shift less than 105 degrees. Okay, and we are done with that. Now to get our teeth, we can as well make this line here to make things easier for us. So this particular line, we can just mirror it, mirror along this line. Okay, so With this now, we're going to draw one teeth on this position. How? We will draw our base circle first. Okay, how do we get the base circle? Base circle can be obtained by the intersection of the pressure angle lines, and the pressure angle is 20 degrees, right? So take a line, you draw the pressure angle from this place like this, because one teeth will be from this place to this place, right? So 20 degrees to this place will be 110 degrees. Watch it. Let's use, you know, longer line, say 50, shift less than 110 degrees. That gives the pressure angle. So this is the pressure angle line. Okay, so we have one side of the pressure angle. Now for us to have the intersection of the pressure angles at tangential, it will be tangential at this place. What I'm saying in essence, we draw a horizontal line here, right on that, tangential to the pitch circle at the pitch point. This is the pitch point. So at that pitch point, we'll draw another pressure angle like this, 20 degrees. Okay, so I'm going to use a line. Here is 0 degrees, here is 90, here is 180, and I want to draw 20 like this, which is 200 degrees. So let's say 50 units as the length of the line, shift less than, and then 200 degrees. Okay, now do you see this intersection? The intersection of the pressure angles will be at 90 degrees. What I'm saying here and here is 90. Measure and see angular between this line and this line is 90. You see that? Why? Because we're going to draw a circle here now, you know, which will make this pressure angle line to be tangential. So, and that circle will be called the base circle. From this place to this place, that is the base circle. This is where the centers of the arcs for the teeth will be drawn or will be located. Okay, and we just need one. Now that I'm done, I will delete the pressure angle lines. Now I have my base circle, right? And I have the center of the teeth will be around here. So for us to have the first center, we will take a circle and draw from this place, because we already have the location. You know, we know that one teeth will be on this side, but the center will be here and to this point. Now we have one of the profile. Look, from this place like this is one of the two profile. So we're going to trim it, trim this place and trim this place, and delete the rest. This should be gone. Now this is an arc for one of the, you know, tooth profile, so we are going to need to find another arc. So this particular opposite side will be the center of the second arc. Are you getting it? There are numerous ways to draw this. I can show you other ways later. So look at this. You will draw this now, not to this pitch point, but to this pitch point. Okay, look, pitch, pitch, pitch. Okay, so pitch point, because this is the pitch circle, not to the base circle place. This base circle is just the center, which is center, but what the arcs will start from the pitch point right there. Now trim this and this. Okay, we're done with one of the teeth. Every other thing will be smooth for us. We can delete this line, it's actually unnecessary now. Now what we're going to do is to just, you know, this is the profile, like this, coming down straight, and this going up. We're going to trim this, and this, and we'll trim this too. You know, this is the random circle, and trim that. Okay, right now we can delete 1, 2, 3, 4, 5. Okay, we're going to select everything, don't leave anything out. That's okay. Polar array, center. How many units? 12. Do you see that? What does this mean? Look at, from this corresponding side to the other side is one circular pitch. So the tooth thickness is circular pitch over 2. That is, from this place to this place, CP over 2. Although that would be an arc, right? It will be an arc. But if you ask for the chordal length, it will be a straight line to that point, which is a chord, right? So this can be gone actually, and this should be gone. Okay, we're going to take a trim this, that. Okay, we have this, all that trimmed out. Okay, now how do you feel after drawing this? Although we are not done, let's look back at our design. You observe that there is a bend, a little bend here. What is that bend for? This particular bend is the radius of the radius of a fillet, and that fillet will be obtained from the clearance. So the clearance is what, 1.25 millimeters. So we're going to use that to make a fillet around it. We'll also use the same thing as fillet for this, but before you can do that, you will have to explode the design, because this is an array, so you will not be able to fillet until you explode. Okay, now we're done exploding. Now they are on their own. Okay, so fillet radius 1.25, select multiple and begin work. Okay, trade, that will be 24 sides, 5, 6, 7, 8, 9, 10, 11, okay, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. This looks like there's sharp edges, right, on this place, so you can apply little fillets on them, but for this tutorial sake, I don't want it to be too long. We'll do more research and bring you better videos later. So we're going to use this now, and from here we will join everything together. J, so let's see, you know, it's a single profile right now. So we're going to draw the key up on this design. We'll use, you know, maybe radius of 8 mm. Okay, then for the key way, you know, where the shaft will be locked on, I think we can use something like 5 mm. So from here we can draw some construction line to help ourselves. Okay, then offset from this place to this place, maybe 2 millimeters. Let's see if it will work out. That will be too big. Let's use 1 and 1. Okay, and let's offset this up. If the radius is 5, you can use 6.5 and see. Now we are going to trim. You will get what I'm trying to do. Okay, you can see that's what I'm trying to draw. You see that? Now we'll join them together as well. Join. So we're going to do something now. This is a single, this is a profile we're looking for, and we're going to use solid. We're going to go to solid. So now from here we're going to press pull the distance between this place and this place. Okay, try to bring it close and highlight that. Okay, so 25 units. Now we have that. Let's check what we've done. Shaded. Okay, you can see the hole, right? Now we're going to extrude inside from this up by, let's say, 30 units. Okay, we're going to do the same here by 5 units because the whole length is 25 and this will be 5 units down. What happened? I'll try again. 5 units. Okay, you can see this is the GA design. Look at it, quite cool, right? So our next video, we're going to make 2 GS meshing with each other, you know, meshing for rotation. Although this one is actually the same. What we're going to do in the other one will be as simple as this as well. There's nothing hard in there. Just have to get one teeth profile, one of the profile, and then mirror, use an array command to get everything. Now we're going to just put some color on this work. So we're clearing properties, and as usual I'm going to put green color. Okay, well, if you prefer yellow, fine. I want to put color on this as well, and say red. Look at this, quite awesome. Thank you for watching Incotech videos. Subscribe to the channel and always come back. You know, if you have any problem, just drop a comment in the comment box below, and everything will be attended to. Thank you all for watching. Okay, see you in our next video, guys.